Oh, yes, now it works. Thank you very much. You know, computers. First, I would like to thank the OCP for this great event and also for inviting me here. And also want to thank the panel members from this morning. A really great panel, so thank you, all of you. This is my presentation, OCP Energy Data Centers and Society, New Applications and Metrics. My name is Terenius. I'm finishing up what I believe is the first PhD thesis in this subject at Lancaster University, is where I am. This is actually some photos from where I am. And all of the pictures are mine, of course. So I've been 10 years in the IT industry, then another 8 years as a lecturer. Actually, I'm back now lecturing at Uppsala University in Sweden. And right now, I'm writing up the thesis. I would like to start this presentation quoting the OCP subproject from heat reuse. Almost 100% of energy used in a process returns into heat. We know that. With proper design, data center cooling systems can be converted into a heat source and a heat management opportunity, as we were discussing during the panel. That in turn converts the heat from a liability to an asset. And this is sort of the starting point of my research. And as we know, the data center industry, and as John was just pointing out, the data center industry uses about 1% of the world's electricity, which means billions of dollars or pounds or so, megatons of carbon emissions. And we get a waste heat of, this is something weird with the formatting here from when we run the computer here. But anyway, this power turns into waste heat, 35 degrees or more if it's liquid immersion cooling. And my question is, how can we reuse this lukewarm heat? If you look on the right, we have sort of the truth. PUE doesn't give you the truth, and you all know that. This is the truth. We have incoming heat, or incoming energy. We have the data center, servers, and there we have cooling. And then we have heat reuse, if we do at all. So this little tiny area, about 12% if we think of worldwide PUE, is what PUE covers. CERT, flops, cover the entire data center, but is limited to that. ERE, ERF basically covers this. DSS, which I'm going to talk about today, covers all of this. So what have I been doing? Well, first of all, I looked into novel applications for data center waste heat use. And I'm actually speaking of waste heat use, because we're not really reusing the heat, are we? We are using the heat. It was something else before. Then I mapped these applications to different geographies and societal structures. And these are my photos from Malaysia, speaking of the question we got earlier today. Tea plantation and strawberry farm. Then, in order to measure these things, I needed a helpful metric, so easy to understand, easy to use. The beauty of PUE is that it's easy to understand. And then finally, I wanted to prove the metric through use cases, and this is my research. So what do we have in terms of applications for data center waste heat use? Well, we can heat a society. And this is something we know. Thousands of homes in the Nordics. I just heard Meta talking about Odense in Denmark. But we can also do this on small scale. A month ago or so, I visited an apartment building in Basel in Switzerland, where they had a liquid immersion cooling tank in the basement. We can also heat swimming pools, like what we will do in Blackpool, which is going to be a new European data center hub. But apart from these things that we already know, what else? Well, for one thing, we can dehydrate commodities, and that has also been brought up earlier this morning. So, for example, wooden pellets. And this is a photo of mine from Falun, where we have the Eco Data Center, if you've heard of that one. These are tree trunks, and these are piles of wooden pellets, partially heated with the waste heat from Eco Data Center. And I mean, if you look at the dimensions, this is like 50 meters or so. But I claim we can also dehydrate many other things. Timber, millions of tons, for example, of timber, depending on where you are, depending on location. Seaweed, I'll come back to that. Vegetables. And to conserve and preserve nutrients, conserve the vegetables. We could do this in, say, Ethiopia. 100% hydropower in Ethiopia. But we do have regular famines. There is an ongoing famine right now. Not in Ethiopia, but in the Horn of Africa, not far away. These come with every 3 years. So I knew 12 years ago that we would have a famine right now, and we do. We could preserve nutrients and by actually dehydrating a lot of those vegetables. Tea leaves, for example, as well. We can store heat by charging salt hydrates. A nice thing about that is that we'll leave heat as is instead of using heat pumps, for example. We can also dehydrate bioorganic matter to trap CO2. I was speaking about that in Switzerland as well a month ago. And we can provide other industries with heat. Greenhouses, marine energy, in this case OTEC. Won't go into OTEC today. A month or so ago, I reached out to Peter Judge at DCD, a great person. And we discussed data centers and the tomato crisis of the UK, if you heard about that, the shortage of vegetables. Well, they could have easily prolonged the growing seasons with the greenhouses. A more blue sky project that I've been looking into, well, blue sky was a fun pun actually, is a sustainable aviation fuel. That is something that we could do pretty much all over the world, also in developing nations to provide an income, using dehydrated seaweed, and then we could all fly sustainably. And note that regardless of, say, how viable is this, or how much do we gain, I mean, for a data center player, this is a good PR value. We saw that a few weeks back in UK, where just a rack of computers were heating a swimming pool, and we've been doing this for 15 years. But still, or not we, but in Switzerland they have. But still, that brought some media attention also by the BBC. Okay, so I've been looking into Costa Rica, and I see Max here from Uptime, and who like this coffee bean dehydration idea, where I claim that we could dehydrate all of the coffee bean harvest from Costa Rica with 50 data center containers. Actually, we could do it with fewer. Sweden, I went to Luleå. And this is the fourth, I think, addition to Meta's, or then Facebook's data center, European main data center site. In Malaysia, it's much trickier. The Nordics is easy. The tropics is trickier, But that is where you have half the world population and a growing population. That is a future market for the data center industry. So keep that in mind. Therefore, I went there. This brings me to the third and final part of the presentation. We need new metrics. As we said before, ISO PUE, or just PUE if you prefer, is good for what it's supposed to do, but it's a financial metric, as was pointed out by DJ, I think. It's not a sustainability metric. But still, it's used in this regard in China, the Netherlands, Singapore, and maybe more countries today, to only allow for certain data centers. But as I said, it only gives 12% of the truth. I'm interested in the whole truth. There are some interesting downsides with PUE. The more efficient servers, the worse the PUE. The more heavy AI compute, the better the PUE. Thus, we need a new holistic metric. And the metric that we propose from my research group includes all parts of the energy chain. So input, the data center, and the waste heat. We call this, for now, Data Center Energy Sustainability Score. Maybe it should be called something else. It's not really of my main concern. So we take energy in, energy compute, energy reuse. And then to also keep in mind, or to keep the beauty of PUE, the easiness, we do this crude but more correct, obviously for heat reuse and for overall sustainability. So we take 3 times the ingoing energy, because if it's renewable and hydropower, for example, and this hydropower is not really going to be somewhere else, but we can actually use it to full, then it's benevolent. If we reuse it, it's good if we reuse energy, because then we're just using the data center as a heater with some added data. What happens inside the data center? I don't think it really matters that much, because what we have, except for server work, and this is the worldwide PUE, if you look at hyperscalers, it's almost all server work. I mean, what we're addressing there in cooling is really not that much in terms, in comparison to the entire energy chain. Thus, I've been mapping these PUE and DSS DSSS to different cases. And if you look at the first 3 here, you see they are from Cyberjaya, so in KL or Kuala Lumpur. Current energy mix, no heat use. Current mix, what commodity dehydration? Could be cardboard, could be seaweed, could be timber. Mango. Or 100% renewable energy, which they don't really have because Malaysia is an oil state. And commodity dehydration. And if you just look at the first 3 bars here, the gray is PUE. PUE doesn't care about these other things. It was never meant to do it. It was never designed to do it. But the DSS, for that part, it really makes a difference. So obviously, it is a much better overall metric. And it takes everything into account, so it should be. If you want to see more of these, and I'm sure several of you do, feel free to look at this in this paper that describes them. It's a long paper, but it's an easy read. It's also open access, so you can just read it. It was recently published in Frontiers in Sustainability and edited, the main editor was Deborah Andrews. Okay, so my final seconds here. I want you to, if you're interested, please engage with Open Compute. Join the sub-project community here. Great presentations in this group. And also contact me if you have ideas. Also, I'm looking into, well, future work right now. I don't know how long I will stay in academia. Yeah. And anyway, I'm interested in hearing what you're doing over LinkedIn, for example. So, to conclude, let's collaborate. Let's move beyond the data center when we're thinking about these matters. Thank you very much, and the questions.